So I was looking at this one. Interesting. So what do we got here? Carbon monoxide. Interesting. And there's lots of ways to deal with this stuff. I mean, I don't see how it's such a problem for today's world, to be honest. There are many ways that could be utilized to probably make this no longer a problem. Let's just draw a cup of water for a second. Let's put an electrical charge in it. So if it's under pressure, so atmosphere pressure equals that makes that into a liquid. A lick. Yeah, let's put the water level in there then. Which we understand is hydrogen and oxygen. So if we put an electrical charge in there, minus and plus, at liquid, it's going to try and create more pressure. If we put something over there to encase it and it can expand, it's going to convert this liquid into a gas of oxygen and hydrogen, yes? H2O, oxygen and hydrogen. So, ho, oh ho. We could do a ho 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 if we wanted to. Anyway. But run away with the process further, and what else do you then begin to make once the water has gone out from the electrical charge? Well, we could then make ozone from the oxygen. I'm not sure what the hydrogen does. I'm not sure if the hydrogen comes together or not in this process, because we've contained now two gases. But what happens if you then were able to separate those gases and put hydrogen in this balloon? And again, without experiments, how do you know? How do you know? And you begin to fill this one up with the hydrogen that you've separated from here. So this will take the hydrogen here, and this balloon here will then begin to fill with oxygen that you take from here. And now you've separated the gases again. Now what happens if I then take another one of these with an electrical current in it, and I put the oxygen into a liquid and repeat the process? I wonder if that's even anything that would work. Would that convert that to ozone? No, perhaps not. So what about if I build a Tesla device then? Where you have the big lightning bolt, the whopping thing, that then goes over to you. Now, let's say if I encase this environment, and I did this process here with the lightning strikes coming over to here, am I going to have this room full of oxygen? Am I going to turn that into ozone? I'm not sure, really. I'm going to draw it all ozone. And I can convert the gases this way. Now I was looking at carbon monoxide. What happens if I put that into a liquid under pressure? And let's get another pen for this. So we see that lightning in water, in liquid, seems to separate. But then when it goes to a gas, it then seems to fuse. So it's almost like it defuses and fuses. And that's an interesting thing. Very interesting. It sort of sits with the principle of the whole universe, really, doesn't it? The black hole and star. Either or. So if I made liquid carbon monoxide, and let's say I put it in here, and I did the same thing under a lot of pressure in order to make that into a liquid, and I put a charge into it, am I going to separate that into carbon and oxygen? And if I am, is this going to cause it to, because we're going to overpressurize it, right? Sure as hell that if it's a liquid under that pressure and we put a type of, I don't know, balloon, but there's enough pressure in the overall system, so we put it in a pressure chamber to add in extra pressure in order to make that gas into a liquid in the container. And then once it's a liquid, we can move it into the container. That's interesting. Pump it into the container. While it's in the container, it can meet this process of the lightning bolt through the liquid. Is it going to separate these into gases? Because now there's the pressure that's in there, and it's going to increase the pressure, but with lightning. So it's going to be extra pressure. Because to turn that into a gas, the system is going to overpressurize, isn't it? So it might start at certain pressure to make that carbon monoxide into a liquid. And then if add the lightning, it's going to depressurize the liquid in some way in order to add more pressure as a gas state. Is this what will break the bonds apart? Is it enough to break the bonds apart the same way that you can do this with water? And then you can separate oxygen and hydrogen. Then if you can separate those gases again, or do they bind together? That's another question entirely. Do I have to release the hydrogen as you go? Interesting. So then could I add this process to be able to sniff the gases and take them off? So you can make a CO2 alarm, but now can we collect these molecules? Yeah, being able to make these attracted to something would be an interesting process. Anyway, it's still asking a question. I'm not 100% sure whether this would work. Anyway, but if I want to take this to space, can I then separate these bonds that way? Because space loves to pull things apart, but I want to allow it to separate, but I want to be able to collect it. So if I also use a balloon and take all of this carbon monoxide, can I separate it in space? And that would seem a bit extreme, but it depends on how much you want to repair the environment. And then can I bind the carbon with some hydrogen? Can I bind it with some oxygen? Can I remove it? And then how many gases can I remove in this particular process, whether using space? And if in a balloon, the balloon's going to be very small to start with, and I have a gas in there, am I going to pull it apart? Do I need to make it into a liquid? Do I need to freeze this somehow? And then allow the sun to pull it apart? And utilizing space and heat, can I remove this gas? And the balloon is going to fill out to so much, but it's never going to be the same. Why? Because when I blow up a balloon on the planet, I'm pressing against the atmosphere. So the pressure of the atmos is factored into it, but in space, there is no atmosphere pressing on that. So there's more of a pull as opposed to a push. And I have to blow into that, which creates the resistance, right? So then that increases the pressure inside outside, doesn't it? Well, I'm increasing the pressure against the atmospheric press. And what does that do in space? If it's a vacuum, what does it do to a balloon? That's an interesting thing. I can't process this at all. So therefore, the balloon in space must get smaller. No? Does it? Do I need to push a lot more? Does it make it bigger? Interesting. Very interesting. Especially if I wanted to eliminate these certain types of toxic gases and make them no longer toxic. And then how does space deal with this? That if this explodes and we exploded I don't know, a carbon monoxide type gas in space, you mean to tell me that space can't even pull that apart? I'm pretty sure it can. Pretty sure it will pull those apart. The same way it pulls away water, but does water become a gas? Yes. But why does it separate? Why does it not make a different gas? Is that because hydrogen is hard to bond with things? Ooh, there's something here. And Tesla, But this is in the atmosphere. We're in pressure. Pressure, lightning, and lightning separates. That's an interesting thing. But it also binds together. So lightning is dual in nature then, depending on the ingredients that goes into it. Pressure chamber. How much pressure do I need to do and pressurize carbon monoxide to turn it into a liquid? While it's collecting into a liquid, can I then pump it under the pressure to put it into a container while under pressure? And then can I hit it with lightning and can I then make it separate? Because this one needs a physical lightning bolt. When you see it, that then begins to fuse. So that's intensity. But even on this, it needs a low current, a low and steady current. This is more of a high current. And again, these are all ingredients, aren't they? Yes. The intensity, the energy that's needed to fuse that seems like it's more. This seems to defuse, it needs a low current, low and steady, high current. Or is it the pressure? Because this is extra pressure. And therefore, although we don't see it, that when it's changing this, there's more pressure being made in the process of Lightning, interesting. It's a very fascinating thing. It pulls things apart, but it also pushes things together. It fuses and it defuses. God, how two-faced can you be? Welcome to the club! I'm not going to shake the lightning bolt just in case it's on off. It also makes intelligence and it can also remove it. That's interesting. But again, without further study, how would you ever know? And then can you pull apart all of the bad gases and then voila. Again, it's a fascinating thing. How do you make petroleum? That's interesting. And is there a way to make petroleum? Because if it is making, because once you have figured out this process of being able to do something about carbon monoxide becomes a thing of the past. You no longer worry about it, and then trying to make a self-fulfilling prophecy out of a fuel source. And there is a third way to go at this, is to genetically modify a tree. However, if those trees end up dominating and you run out of carbon monoxide, which you would do eventually if you made a tree that was able to deal with it, and if it took over and it ended up eliminating nature and did some other things as well, that would become the current nature. And without a fuel source to supply it, everything dies. Cool. What a balancing knife edge this could be. So again, it would need to be contained. You couldn't just go and plant these out anywhere. It would have to be done as a very careful experiment. Which, again, I think something higher would lean into that. Wait a minute, that's interesting. Oh yes, and defusing. And lightning seems to be a very good factor. Liquids into gases, which is incredibly interesting. And again, if you look at this a little bit more so, why does Jupiter have so much gas? And we look at Io. Man, that thing is hitting lots of lightning bolts across the equator, doesn't it? Is it the equator? I think it might be closer to that. Anyway, it doesn't matter. That's an incredible amount of energy, especially little old Io. That's a lot of So yeah, if there was any liquids on there, even water at one point, then Io would have converted that into ozone. If you've got something in there that's sniffing for oxygen, what happens if you have it so it's sniffing for ozone? Would you find more ozone? Because something is keeping this pressure going. I think it's Io in Jupiter. That's interesting. Very interesting. Actually, I think all of the moons contribute. That is fascinating. And again, you can create some sort of process like this, which is a lot of energy, a lot of friction. And if you just tap into some of that energy, you can power a lot of stuff. Yeah, off that friction, which then creates heat, which then keeps the core of Jupiter metallic. Yes, maybe. And Mars doesn't have this. Mars is the odd one out. Mars is always odd. You're so odd. But is it because you lost a moon and then you cooled down? Because something sustained you, but you lack gases. But there again, isn't Mars venting gases? Doesn't it make a sort of, if you squint right, do you see some sort of gas trail coming off of Mars? Slowly but surely, Mars is losing its atmosphere. So maybe it did puff up, and that's what made it move closer to Jupiter, and that's why it switched with the Earth. Well, maybe, if you believe such a thing. I think Earth's alignment with Mars and Jupiter is wrong. Earth looks like Jupiter a lot. And Mars reminds me of Venus. Interesting. Yeah. But there again, Mars, now smaller, must be somewhere in between Venus and Mercury. Yeah. Interesting. And Earth Wow. Somewhere between Jupiter and Venus. Ooh, that's a hell of a shift. That's if they shift. But some sort of alignment issue. And there again, if you couldn't test all of the soils from this, you wouldn't know. And there again, are the planets near enough half and half? But is that in creation though? And there's a lot of maneuvering and bombardment take place. So the further down you dig, and there again, if they had moons, that's a lot of deletion, which makes it tricky to analyze, especially with the Earth. It's a constant regenerating crust. If they all had no regenerating crust, how would they all look? Did they line up in this particular way? And if they did, these debris here are going to be slightly different to these debris here, but yet this is going to take some from here and some from here if we look at the rolling factor. And then these debris are going to be here, so that's like a almost 50-50. It's not quite a 50-50 ratio, back and forth, a rolling, which then means that this would have similar composition to Jupiter and Earth, would have 50-50. Interesting. So therefore, it's somewhat similar to each one. That's if you could pause it. Yeah, I don't know, maybe you could figure this out, but knowing an Oort cloud and what it's made up of, depending on a perfect Oort cloud, the star starts dominating and the rest are rotating, but they're always staying in their lane while rolling slightly backwards and forwards. And again, how do you get the dust to fall into planets? Because if we look at the Voyager probes, and the scientists say this, they did, didn't they? That they thought it was chaotic going through the Oort cloud, but actually they held their distance from one another. Oort cloud and Kuiper belt. And if something big pushed through that, would it maneuver out the way or would it attract to it? Oh, that's an interesting one. So how does that debris get squashed up if it hasn't squashed up and it's moving with it? So it must have been more rocking. There must have been more pull because the planets were uneven, not in a straight line, not all moving together. And that could trick the gas that another object pushes it out whilst this one pulls inwards. And it's moving towards it, backwards and forwards until it's hoovered it up, until the star creates the decent amount of alignment with the rest, which then it has to get bigger to do so. But if they're all trying to be stars, one will win. And then it takes center stage of the planets. But there again, there would be a very similar composition, but they're also very vastly different, which makes sense for the type of ingredients that were around the star. And therefore they rolled, which fits, doesn't it? It does fit with Uranus and Neptune. Man, their composition is eerily similar. And Jupiter and Saturn. But Mars doesn't fit. They don't fit. Mars looks like it looks like Venus. And Mercury, well, we don't know that because it lost its crust. It's almost like they've switched. These have switched. Why? I don't know. That's if. You'd have to see it in order to understand it. But if Mars moves very strange across our sky, that's an interesting thing. Almost like it's up to something. What is it up to? Could you imagine if those switched? Earth and Mars switched, but I think it's going to go in between Venus if it goes anywhere. There's some sort of it just doesn't fit. Earth is very characteristic of Jupiter and a little bit Venusy, maybe a bit Mars. I don't know. It's difficult to do it because there's been so much shrapnel come over the time where there've been a lot of direct hits from stuff, so it's really messed up the way to see it. But something there, man, of rolling this way, that way would mean that you would get a sort of 50-50 composition trail. Interesting. Unless there are lots of iron in these areas. Which if it is, then the iron that got popped out of a last star is going to be charged at certain ratios, which could then maybe take on, okay, that could work, couldn't it? What keeps the, again, if you can't go towards a nebula, how do you not know that its alignment isn't because there's lots of like invisible magnetism holding things together? And if iron is dominant, even in small particles, isn't this, if it's plussed and it's really charged in the plus, aren't the negatives going to be more gravitated towards it? Interesting. Then that would give you a sort of good mix then in the nebula, wouldn't it? Which would go on to support star formation, which then would probably rub this bit out. But even still, yeah, interesting. There is a pattern with the planets. Yeah. They seem to be very odds and sods. And the further out you go. But if it's because they're bigger and the objects flew into their gravitational influence, then the star should be the most dominant one. So therefore, you would see bigger planets towards the star, and they would get smaller as you go out, not bigger. Unless they were bigger and closer to the star, but the star pushed them. Or they stopped spinning. Everything's got its place. Anyway, maybe that's nothing. Then maybe I'm just wandering off onto something else. But even still, it's worth having a look. Can't be wrong. This plus minus minus plus, depending on where the star exploded, at what type of the composition, the magnetism in the star. There's a lot of magnetic fields ratios on there, and deeper in the star, if it's going to do a flip or not. Could you imagine a star exploding during a reversal? That would make a very different nebula. And then what gravitates towards it, which then might set in motion whether you would have a very big star versus quite a big Jupiter. The plus and minus. Oof. And what is the magnetic field for a star all about? Protect it if it gets too close to a black hole. It can maneuver its poles. So when a star gets close to a black hole, in order to stop it from falling into it, does it rotate its poles? Interesting. That's an interesting thing entirely. And if it does, isn't it orbiting around, as much as the black hole finds the center by spider webbing off the magnetic poles to reach the center, the stars also do this back to the black hole in order to stop falling into it. It's using two minuses to keep it away. And then if it loses this dance, the black hole will win. It will pull it in. If it turns its plus into the minus and it gets the wrong pole at the wrong time, it will lose the dance around the black hole and the black hole will devour it. That's why quasars are not common. And again, knowing that there is this, there's a lot of knowing, isn't there? Cool, it's too intelligent. That would be an intelligent behavior from a star, which would then suggest that it's alive. And it would also suggest that the black hole is alive too, which is an interesting thing. Not in the way that we know it. And there would be an intelligence. It's observing something, and therefore galaxies are known to come together. And again, stars use their magnetism to repel one another in order to find their new orbits. Yeah, you can come through it. This one you want to be a part of?
Yeah.
I'm just processing on this one.
Okay.
Do you see stars as living?
Yeah.
They're alive.
Yeah.
Do you see black holes as alive?
Yeah.
Then you would have to say the galaxy is alive. Mm-hmm. And that same thread that works through all life is also working through the stars.
universe is alive.
Well, the whole thing is, yes.
Yeah.
Life supports life. Therefore, the outcome, more life. Interesting, but still. What do you think the north and south is? Do you think it just looks pretty on a planet? Just to make northern lights?
It's a charge or something magnetic.
So in order for things to be intelligent, it must be able to predict long-term predictions. So galaxies merge together, yes? You know that there are some stars that orbit around black holes. Some stars get devoured by black holes and make these things called quasars. So the star technically is dancing around the black hole. So there must be a north and south with a black hole. And if the star uses its north and south in a correct way, I don't know if I can explain it with a pen, which I can, and now I need another pen. Good. Do I have another red one? Yes. So if this is the black hole, and this is the star, and it's orbiting, if it uses its magnetism, it can push away and never be devoured by. But there again, it doesn't want to go crashing off into other stars, does it?
No.
So do you think it's using, when it goes too far, it uses the pull ratio in order to have the perfect timing to push away, in order to rotate, pull, push away, in order to not be eaten by the black hole itself, but also not to go colliding into another star? And then galaxies merge together, yes? And if they are, then stars need to be on there. How do you merge a galaxy? And I think it was NASA astronomers were looking, I think it might have been JPL, I'm not sure, were looking at the Milky Way, and they were scanning into the black hole, and they noticed that there was this. A merging process happening. But how do you do that without losing all your stars in the colossal explosion, or the same process? Some stars get smashed up in it, don't get me wrong, but a lot of them survive because if they rotate their poles, they can then reach an alignment, an order, and still maintain the Ferris wheel, the carousel, by using magnetism. Which then, if you utilize that magnetism and you start to understand magnetism a little bit more, then when stars explode, then they're going to have particles that are charged in the north and particles that are charged in the south, and an equator that's north and south, perhaps binaries. And then the iron, being the dominant thing that it is, if that's charged in pluses, it's going to attract a lot of negatives. And then you can start to predict what will grow in the nebula without actually but there again, that's a long-term prediction, right? So if you understood the processes of that star that last exploded and maybe another one, you can then determine, based on the particles, predicting how big the planets are going to be, what order, and what type of star composition is more likely to generate from that. And then maybe its size, based on which bits are... Because stars explode at different ratios. So some of them might be during a flip, which the liquids, it's a liquid anyway, you might as well call it that. They're jostling around before it does a magnetic reversal, yes? The reversal, the Earth does it too. Which then means that it's in control of orbits, which if it is, then planets as a byproduct are also in control of it. But when they lose their magnetic field, they're the sun's control. So Mars lost its magnetic field and it dances very differently, almost like it's out of rhythm. So I think the sun has an influence on it, or Jupiter. has got its eye on it. But I think it's too much out of Jupiter's. I think the star will begin to. I think that was going to move. Mars reminds me of somewhere between Mercury, Mars, Venus, Earth, Jupiter, Saturn, Uranus, Neptune. Uranus and Neptune are very identical in type of Jupiter and Saturn. Just remove the rings from there. And maybe if you could squash these up and have a moon that's very close, you might look at Saturn as a Jupiter. And again, think about Io and its many, many amps towards it, which then might start to generate and then begin to puff it up. And if you look at Saturn, it looks like it's sort of been on a journey like that. And things are going to be more solid further away from the nuclear furnace that you are. So you're going to have more ice. And you're going to have less ice and more liquid closer to the nuclear furnace. And what is ice? Well, when you put a little bit of water in a freezer in an ice tray, what happens to it when it freezes? It expands. So, of course, these are going to look bigger towards the end because of the... And therefore, it would mean then that Pluto is a moon, was a moon. Interesting. It hasn't had enough time to grow yet. But once the star is at a certain ratio and it starts the fusion, then is that when the magnetism comes alive? And if it is that why it keeps the Oort cloud? Because if it was building, wouldn't it want all of this? But at a certain ratio, when it kicks into life, it may not be able to accept that, which makes sense because if those objects flew into it, it can stifle it. And then I ask another question: if I were to throw those into a star, can I slow down its age by cooling it off? Which would then mean that I would keep putting these objects into it. I can slow it down because it's not going to be burning hot and fast. It's going to be slowly. And I noticed that when you have fire and I put coal on it, it's raging hot. It's almost melting me to be around it, and then I cover it with some coal, and the whole infrared dims out. And I only put a little bit on there. There's a ratio, any more than 3, and it cools down in order to heat up. It's a weird thing, isn't it? So the energy is aiming into that colder coal, if you want to say that. And as a result, it cools it down in order to move the energy. And it seems to be quite a dance. Fire is a hell of a dance, especially when it comes to coal. And therefore, it cools down the fire drastically just by, and then it doubles up because once it gets going again, it's then twice as hot, which is fascinating that it has to cool down in order to get hotter. And even if I try not to smother the glow, because, some people might say, it's the infrared, you're blocking out the infrared. Well, no, not really, no, because I tried that. I already thought of that while doing it. Let's play around with things. It's just what I do. And then I was looking at carbon monoxide. So what happens if you make more pressure until we make it into a liquid?
Liquid where?
Inside a pressure chamber. So you keep adding pressure of just carbon monoxide, just keep compacting it into a small space until it starts making into a liquid. And that's going to sit in the bottom here. And then you use a pump to pump it into a container. And then you give it a small, low current electrical charge. Will it separate it? A bit like water. And if you separate it again, which water is separated into this process, and then it can run away and make ozone. But then you need high current, and then that's in air, which we often forget that even in that chamber, water is only a liquid because of the pressure of the earth, but carbon monoxide isn't because maybe there's not enough. But there again, there might not be enough pressure. But if you put nothing but carbon monoxide inside here and just keep going until you pressurize it, until it starts making a liquid, and then you move the liquid in here and then add the same lightning, which is a small electrical charge. Is it electrolysis? No. It is, isn't it? No.
It separates more, yeah. It separates the liquid and the molecules.
Yeah, but why does it separate it into oxygen and hydrogen? and we struggle. Do you think it would work the same way in the same process? Do you think it needs more of a current?
Yeah, could do that. Really don't know.
Yeah, I know, this is the thing.
Yeah.
You don't know until you experiment and find out. What about if you take it to space? Is it because it's the liquid that you take to space? Or is it any gas just starts separating? And then why would it separate?
I think that the gas would separate as well.
Yeah, so if the gas separates, then that fixes your carbon monoxide problem. It wouldn't need to be in space for very long, and this would just need to be what? Flung up? So then what happens if you take it up a mountain? Further than a mountain? Shoot it from a mountain? Just so it touches space in some sort of environment that doesn't allow it to go off into space. And then it drops back down, and then you pop it. Does it then remove carbon monoxide? Carbon monoxide, oxygen and carbon.
Yeah.
Because sure as shit, the bands must already be here in order for it to... It is 3, isn't it? No, it might be 2 and 2, is it? The bonds, the binds. I don't... It's not important. It's not important. I don't know, I like to go on these little journeys. I just unpack things and it leads off on tandems. I don't like staying focused in on one thing because that's not how things are discovered. You have to spiral off everywhere. I like doing that. I love it, actually. I'm not going to stop it. Sometimes I will and sometimes I won't.
Yeah, thinking jumps as well, so you can jump from one thing to another.
And this whole planet alignment is just wrong. It just doesn't make any sense. You know, if I ever looked at Earth's twin, it's Jupiter. It's close somewhere between Jupiter and Venus. Sort of like a shade of grey in between there. And then with this whole electrolysis thing, or whatever you want to call it, I don't know if it is called electrolysis. It might have another name. Anyway, then Io, close to Jupiter, well, isn't that then removing the liquids into a gas and then binding these gases into like ozone or other stuff like that, and then it's causing it to puff up? Because if it can do that with a liquid at this pressure, what happens if you had a constant lightning strike on the Earth at the water? Just constantly kept hitting the ocean with lightning over and over and over again, high voltage lightning. Well, then it's going to do the same thing, right? It's going to add more pressure. It's going to puff the atmosphere up. So under these conditions, these ingredients, Earth's oceans are pressure and liquid. But if I put a lot of lightning down into the ocean, I'm going to separate that, yes? And then if I keep on going, even after the ocean water's gone, I'm going to start mixing things together. Then Earth's going to puff up. Factor in the deepest parts of the ocean with the isotopes. They're going to unpack first. That's a lot of atmosphere. I could swell it up to Jupiter size. Io seems to be in a locked orbit, doesn't it? Our moon was close once, but then moved away.
Yeah, it's slowly moving away.
Io isn't. Do you often think this shit is all done by accident, that the moon moved away slowly? Or do you think something helped it?
Something like that.
What about if there was potential for life to be on the Earth, or something flung it in? The moon in. Because it understands evolution. And if these life forms are here in dino stage, well, you'll know that the next chapter after that, once you understand life, you understand it. If you come across a planet with dinosaurs, what would you do? Well, you might sail something into the fucking planet. Because you know that the next thing that comes is going to be intelligent, or more intelligent than that.
Yeah, remember way too big and wild animals with small animals. see what happens.
And would you feel overly guilty about it? Well, no, because
No, then you can go down if you are like.
you were just helping evolution, right?
Yeah, you would be afraid that something would eat you.
You wouldn't be afraid that something would eat you, because
Something
before
monstrous.
you find those things, you would lift them up. You would take specimens, of course, because you need a before and after. But then you would need to return after a certain amount of time. And then maybe it's primitive. And it's still not enough time has gone by. Too primitive. And then you could tweak it because of the universal picture is, well, language, the universal language is pictures. And then you would understand sociology. Sociology, that some things see, they copy, they mimic. If you understand yourselves really well and your species really well and the universe, well, even just this much, there's probably a lot more to learn, but this will teach you something going forwards. What else is there? Change. Factors. And then maybe it answers a few questions for your own species. Well, I never fucking knew that. Well, maybe this is what happened to us. Well, it clearly must have done because it just happened here. Some sort of experiment, right? But in order for you to have that sort of, for it to rest on you just good enough, you would have to take the specimens of the life forms that were there first before doing it. And again, if humans didn't cotton on to this pretty quickly, they might stay a little bit too long, and once that moon has gone, so are you. Maybe. Maybe not. And then that takes time. And then factor that in. Time, life, length. So any species in space are going to live a lot longer. Maybe. And then would it all be about adding to the life force? It's an interesting thing to ask, but still it's a very weird one. What happens if a child was to stay connected to mum for the whole time? Imagine that they could via the umbilical. You mean to tell me that there's not been one culture that has ever tested that? That rather than cutting the umbilical or chewing it off, what happens if you stay connected? Any life forms out there ever tried that? That would be an interesting thing. And then would that give you some insight into longevity? Because you're tapping in parasitically, temporarily. Well, if you think about it, all life forms are parasites. Well, you needed a host, which was your mum. That's a host. That's parasite. That's interesting, isn't it? That's a deliberate parasite. A chosen time of parasitic. It's interesting, isn't it? Life is parasite. Which it is, if you look at the planet. You're a parasite to the planet. The planet's sort of a parasite to the star. Well, you can keep going, but even still, parasitic. You live inside your host planet. That's interesting, isn't it? Do you find that fascinating? Well, anyway, but there you are. There's a little bit of a deep dive, but and a sort of shallow one as well. Pressure and depressurization. And lightning can either forge things together or pull things apart. But the ingredient is different. High current versus, and again, through the air, Tesla, when he's sitting there with his little feet back, sort of maybe going over some stuff with that lightning bolt. I bet that was really nice. It's sparking away and him created ozone that probably, who knows, maybe the hole was worse back then. And unknowingly plugged a hole in your ozone layer without you even knowing about it. because you weren't looking, but something else was, and maybe took the steering wheel. Ah, yes. Anyway, life supports life, and life is, yeah, but yeah, definitely that. In order to make a smoother orbit around the black holes when they begin to merge, so Andromeda. So that's a long-term prediction, very long-term prediction, and to see if you're right or not, that's something, isn't it? So Andromeda is probably going to happen quicker than it's been stated. It probably gets faster the more closer it becomes. And some of the stars, well, are going to be in the process. To the black hole, it's feeding time, and it's a chance to learn. Chance to learn Andromeda, and they'll share the information whilst they're merging. But while they're merging, they're going to also be feeding until they get to a certain time limit in that, and they no longer feed. But they're going to be learning the information from one another in that. What's this one been making here, the Milky Way, and what's Andromeda been making? This is new information. So they can merge, but also feed at the same time, and also learn. Which then might be it trying to predict it before it merges and gets whether it made that prediction correctly or not. Because the longer the time that they've got to chew on these ingredients, the more they're able to separate them, especially if it's a harder object. So the star takes a long time to build up to making iron, and these ones are going to take a long time to defuse from there, so they probably start with the easiest stuff, bit like a roast dinner. Which my grandfather said to my sister that there's a way to eat a roast dinner, a certain way that you should do it that's good for your digestion. Fascinating. So interesting. So yeah, cannibalistic. It also eats life, a little bit of meat, with a little bit of other stuff too. So it's learning a lot of stuff. So anything that gets in there, don't let any humans get in there, will you? Or remnants of it, because it will learn how to pick you apart, and it is more intelligent. Yeah, think of it like a frog with a very, very big tongue to a fly. If it knows you, the less it knows, the better. Because it will take time to learn that. You probably want to be shielded in an onion layer against that. Give it something to chew on, like a gobstopper. Each layer getting more difficult. So as soon as it's broke through one layer, it thought that was hard and it won against that, and then it meets another wall that's even more hard and more stronger. By that time, you're inside it, which adds up to the volume, and then it pops, which then saves you. And those ingredients, to get those ingredients, is more than just putting stars together. So, later, maybe later. As Jesus probably said, if there were Easter eggs around at the time, don't touch my eggs. Why not? We're back Sunday. Don't you think so?